Hi, this is FileSaver back with another video, and today I will be showing you how to make biuret. Biuret is a useful reagent and you can make several compounds with it. Here are the formulas for making it. At 150 degrees Celsius, urea turns into biuret and ammonia gas. However, at 170 degrees Celsius, urea turns into cyanuric acid. We can, however, separate it when making biuret by just dissolving the biuret in water and recrystallizing it. Biuret is really soluble in water, while cyanuric acid is not. As you can see, the reaction requires 2 moles of urea. The molar mass of urea is 60 grams per mole. I will be doing this on a half a mole scale, so I will use 60 grams of urea. Firstly, begin by measuring out your urea. I will use 60 grams for this run. Secondly, measure out your catalyst. I am using 5% of boric acid. This is 3 grams. Now that you have all of your reagents gathered up, put them on a hot plate. Use a setup that will look like this. Here is the urea being heated. The ammonia gas will make its way around here, and into the water so it dissolves. This is to prevent any ammonia gas from escaping. It will make this a lot more pleasant. Make sure you are not using a closed setup so ammonia gas can escape. Just any gas can escape, otherwise pressure will form and your setup might explode. Now, it is also important not to put the tube in water, so any water won't just get sucked back in there into this flask, because it dissolves so much that it would just get sucked back. It's also called suckback. So it would just get sucked back into this reaction flask. This is the setup I will use. Here is the thermometer. It is very important to have a thermometer and keep the reaction above 150 degrees, at approximately 155 degrees. Now, I have used tape because I don't want to use any jointed stuff, because it might get stuck in this reaction. You can do so, but do so at your own risk. Here's the glass tube. That's the way for ammonia, and this beaker is filled with water. It is connected to here. There are also several air holes in here, so the gases can escape and no pressure will form. This way, no ammonia should really escape out into the room. Now turn on your heating. If you have the possibility, turn on stirring. It is important to have stirring for this reaction. And wait until the urea melts. Also make sure this doesn't get above 150 degrees. Otherwise it will just turn into cyanuric acid and you will not get any biuret at all. Now that all of the urea has melted, keep a close eye on the thermometer. Make sure it doesn't get any over 160 degrees. Stop the heat and take it off the hot plate immediately if you see it getting cloudy. If it gets even remotely cloudy, this means that the reaction has completed. I will hopefully be able to show you what it will look like. Now, exactly 30 minutes from when it melted, it has turned cloudy. This is the sign to stop. Take it off the hot plate and slowly let it cool. Keep the ammonia trap on it because it will keep releasing ammonia gas. Just let it slowly cool. Now, as it has all dried, add 150 milliliters of water. Use distilled water so you won't get any calcium carbonate or any other contaminants that could possibly be in your water contaminating it. This should be enough. Don't add too much water, otherwise you'll have to do so much evaporating. Now stir until as much of it has dissolved as possible. I am using a spoon that I only use for chemistry, as you can see, so there is no danger of it being used in food. You will now be left with a mixture like this. Filter off all of the insoluble gunk, like this, and you're left with a solution of biuret and boric acid, biuret, and still a little bit of urea. Just wait until it's all been filtered off. Now, after filtering it, boil it down until it has 40 milliliters of the final solution. Then let it cool down slowly. After that's done, just put all of this on a filter paper and let it slowly dry. My final product after drying. It seems to be quite pure and there are small crystals of it in here.